This is example 12-2. We have a channel with a width transition, right? So we go from flowing from A to B, and we can say that at A it was 4 meters wide, and now at B it is 3 meters wide. We're given that we have a flow of 900,000 liters per minute, and we're told that at B the depth is 1.25 meter, and now we need to find what the depth at A is. So I think the first thing that we'll do is we'll just convert our Q into cubic meters per second. So we have Q is equal to 900 times 10 to the 3 liters. Now liters, there's 1 cubic meter per 1,000 liters. And the other one is minutes. And of course we have 60 seconds per 1 minute, which gives us 15 cubic meters per second. That's quite a bit of flow there. Now we can go ahead and figure out the specific energy at A and at B. And we of course know they have to be the same. So let's start with A. EA is equal to V at A squared over 2G plus the depth at A. Right, that's our definition. We can say that's the same as the flow rate over the area at A squared divided by 2G plus YA, which is then the same as Q squared over 2 times G times A squared plus YA, and that is equal to Q squared divided by 2 times G. We have a rectangular cross section, so we can say that would be B at location A squared times the depth at A, YA squared. Right, the square comes because it was squared. Oh, let's not forget plus YA. All right, that was at A. Now we can do the same at B. I think we can just write it out. All we have to do is change the subscripts, so we'll just write it directly. B is equal to Q squared over 2 times G times B squared times Y B squared plus Y B. Right, that's our specific energy at location B. Now there's nothing happening in between these two sections, right, other than this width transition, which means we're not losing any energy, so it means specific energy at A has to be the same as the specific energy at B, which means we can write our whole thing there. So Q squared over 2 times G times YA squared times BA squared plus YA is equal to Q squared over 2 times G times YB squared times B squared plus YB. All right, let's see. We are trying to find the depth at A, but we know everything else. Let's see. So we know Q, G, of course. We know everything at A. We know the width at B. So the only thing we don't know is A or B at A. Okay, so we don't know what YA is. We do know what YB is. So that means we can rewrite this all in terms of YA, and we can solve that then for that. So let's see what we get. So the first thing that we'd want to do is, first we'll multiply everything by YA. So that means we would get this one here, just gets rid of the YA. So it'll be 2 times G times BA squared plus, now if we multiply that by ya squared, we get ya to the third power. Here, multiply by ya squared as well, so it'll be b squared times ya squared, and then same with the last one here, yb times ya squared. Now if we reshuffle this into our standard form, right, then we can say, if we start over here, right, we have ya cubed, then we have some square terms, but they're on the other side, so minus q squared over 2 times g times yb squared bb squared plus yb. All of that is times ya squared, right? The term here and the term there. We don't have a ya term, so 0 to the first power we don't have one, but to the 0 power we have q squared over 2 times g times ba squared, and all that is equal to 0. Of course, this is a third order polynomial, so we should be able to solve that relatively easily. But to do that, we need to put some numbers in. So let's see if we can fit this all together. Ya to the third power minus q was 15 cubic meters per second squared divided by 2 times 9.1 meter per second squared times yb was 1.2 and bb was 3 times 1.2 meters squared times 3 meters squared plus 1.25 meters, and then that times ya squared plus more or less everything we have up here. We don't really need a bracket in this case, so we'd have 15 cubic meters per second squared divided by 2 times 981 meter per second squared times the width at B was 4 meters. Squared equal to 0. So that means ya to the third power minus 2.0654944 meters times ya squared, right? It has to be meters because this is going to be meters squared, and it has to connect to the meters cubed over there. Plus 0.7167431 meters cubed equal to 0. Now we can solve this using whichever approach you prefer. I like to use Python on NumPy, but pretty sure most of your calculators will be able to do that too. Now if we solve this, we'll get 3 solutions. We'll call them ya1 is 1.85784 meters, ya2 0.73357 meters, ya3 equal to minus 0.525, that's a 5, not a 9, 0.591 meters. So we already know, of course, that the last one, negative, that's unrealistic, that's not going to work. But that means we still have two values left. Right? We have 1.85 and 0.73. And so now we have to decide which one of those is the correct one, right? Because one of these is going to be for subcritical flow and the other one is going to be for supercritical flow. We can take advantage of the fact that we know that if we have at B, right, where we know all the values, if we have supercritical flow there, then we'd have to have supercritical flow at A as well, or if it's subcritical, it would have to be subcritical. So to determine that, we will find the critical depth. That will be YC, right? That is Q squared over B squared times G to the 1/3. So that would be 15 cubic meters per second squared divided by 3 meters, the width at B, times 9.81 meters per second squared. Not forget to the 1/3 power. And that gives me 1.36591 meters, right? So this is the depth, the critical depth. So anything above this would be subcritical and everything below this will be supercritical. So if we go back, we know that our flow was 1.25 meters at B. That means we're lower, so we can write at B, YB is less than YC, so it is supercritical flow. Critical flow. Now, if it's supposed to be the same at A, right, then we know that, of course, we have to choose 0.7 because it would be also supercritical. So that means YA is equal to 0.73357 meters. Let's do supercritical behind here. And with that, we have our solution. So we figured out that the depth at A would have to be 0.7 meters. If at B it is 1.25 meters, and if the changes from 4 meter width to 3 meter width.